Another draft physics video production. More on the same subject, comments, and it's probably worth beating it to death. Certainly it proves the point. I mean, somebody's obviously right and somebody's wrong in this conversation, right? That's what we have to accept. So somebody's invested an awful lot of energy arguing a misguided or foolish point. And I would say in this case foolish because it's just so obvious there has to be a difference between the object moving and the object not moving. There's a difference between me jumping on a train and me not jumping on the train. When it comes to Redshift, huge difference. And they're pretending there's not. And so anyway, so superior mind is interchanging with this. They're doing this math in their head kind of thing of, well, if you go 7 units to here and then Mary buys 4 units of this and then they, I mean, no, sorry. I can't play that. You got to draw it. But anyway, so we'll deal with the other comments. So, Biz's Woot, another stupid Woot account. Your mistake is that you are making the dragbacks collimative. Well, they're collimative in the sense that the extra wavelength happens to each bit. Each bit adds more distance. The distance isn't added to some total somewhere. The distance is added each time they interact. The wavelength is extended because the distance is extended each time there's an interaction. And only when there's an interaction is the distance lengthened. But so they certainly do add up. If I make the wavelength an inch longer each time, the inches add up. But it's not terribly relevant. Just as I've tried to point out, it doesn't matter where the interaction takes place. It doesn't matter even if I put the fourth bit, the last bit, in the trap first. And then I put the second bit in the trap second. And I put the third bit in third, and then I put the first bit in fourth. It doesn't matter which order they go into the trap. None of this matters. All that matters is they go into the trap in a forward position, and they come out of the trap in a negative condition. Negative to where they were. That's the added distance. You can't get around it. Each bit is affected independently. Exactly what I'm arguing. But independently, they're adding more distance to the total length. Let's draw a timeline with units of light seconds. No, let's not. So more of this. A, B, C are bits moving at the speed of light. 1, 2, 3. You couldn't do that. But anyway, H is the hydrogen atom moving. Okay, opposite. The hijack interaction takes exactly 2 seconds. How long it takes, again, is irrelevant. Okay, because we're saying that, yes, they're all going to endure that 2 seconds. But what they're all also going to do, and each individually, it's going to be a unique experience for each one, is they're going to go backwards and then go forward. Yeah, it's going to happen. It's not going to take any more time. It's just going to create more distance. The thing is going to it moves to this point. It stops moving, and then it restarts from a point negative to where it stopped. That distance isn't compensated by anything. It doesn't go anywhere. It's stuck. That's lengthening the wavelength. The amount of distance it goes backward, whatever percentage of the time that is, 2 seconds, 5 seconds, 40 seconds, 4 years, it just doesn't matter. Whatever that distance is that happens in that time, that distance is added to the wavelength. Alright. Takes 2 seconds. At T18, before A, B, and C meet H, C, D, B, and A at T20 is hijacked by H. So again, it doesn't matter what order they happen in. It's totally irrelevant. It doesn't matter if I'm going to break each of the horse's legs in the race. At some point in the race, every horse is going to have a broken leg. I'm going to go over and break its leg. It doesn't matter whether I break it at the finish line or break it at the starting line. It's totally irrelevant. All that matters is each thing's going to endure the process. Every single bit is going to go through the process of entering the atom, getting stuck for a while, being transported backwards, and then being released. And that's the only event that happens. There's no context. You need to tie each event to each other. They're each independent events, and it doesn't matter when they happen in the race. It doesn't matter whether I do it to the horse right before he gets to the finish line, or I do it right when he starts at the starting gate. Doesn't matter. Can't matter. I argue that point. See, this is the problem with the commenters. They pay no attention to the points I make, and then they want me to pay explicit attention to their points. So it's just no. I'm making the assertion, I'm making the video, and I'm providing reasoning for why you can't evade it. So do we agree they're independent events? You just agreed they're independent events. Both of them aren't in the trap at the same time. Both of them aren't interacting at the same time. One goes in, it goes out, then another one goes in, and it goes out, and another one goes in, and it goes out. Independent events. And the event is a closed system. It doesn't matter where it happens relative to anything. It just has to be within the scope of reality. It has to be somewhere between now and then, but it doesn't matter when. It happens between now and some point in the future, as long as it's not past the target. It just has to happen somewhere in the space, and each event is independent. It doesn't matter which order I do them in. No difference, because each one is creating a piece of extra distance. That's the longer wavelength. I just said the same thing slightly differently. Alright, T26B gets hijacked by H. So again, this doesn't matter. You're not conceding that when it's hijacked, it's moved backwards. It will now have to travel the same distance it already traveled, and then do the normal thing. This extra distance wouldn't happen if the hydrogen atom was standing still. So when the hydrogen atom's standing still, there's just this distance, the time. That's it. There's no change. But clearly, when the hydrogen atom's moving, that's when this change in position takes place. And how have you accounted for it? Because it doesn't matter what order it happens in. It doesn't matter where on the track it happens. So if you agree with those two facts, that those two things can't matter, then how did you account for the extra distance? As you can see, the distance between A, B, and C remains 9 units before and after the interaction. No, I don't see any of that. Okay, so frankly, again, you're saying the word hijacked. What does that mean? Do you understand that that means it's not moving forward anymore? That it's now moving in the opposite direction. And when it does move forward again, it's got to retrace steps it already traced. It's backward. It has to move more distance, which will take more time. I mean, you can't... Alright, so let's see what Mr. Monk has to say. To make sense of any of your diagrams, fuck you. They're diagrams, yes. They're not that difficult to make sense of. You move forward, you move backward. Why do I need numbers? I sort of showed it with percentages. I mean, the things are moving. As already established, it doesn't matter what order they happen in anyway. So you really don't need to have a sequence of events where this happens to A, and then this happens to B, and then this happens to C, because they're individual events. So it doesn't really matter order. It doesn't matter where they are when they encounter the hydrogen atom. It makes no difference at all. Alright. This way you can be absolutely sure that everything is proportional. The proportions don't need to be exact, but as I pointed out, I'm cheating in a sense that I just made the amount of time they're held exactly the length of the wavelength. So the only way, what it's going to do is create double the wavelength, and it created double the wavelength. Now obviously in the real world example, it wouldn't be in the trap the entire time, and so it wouldn't move the entire wavelength of distance. But, to illustrate the point that there's so much forward motion and then there's backward motion. All you have to do is illustrate that there's backward motion, and this conversation should be over. You should just concede, okay, it moved backwards. It obviously is going to take longer. It's a longer distance. It moved backward. If the starting line is from here to here, the finish line to the starting line, and I move the starting line back, it's a longer distance. It's that simple. It really isn't any more complicated than that. When the atom, you could just argue that when the photon hits the atom, all that happens is the starting line moves back. And now you have a longer distance to the target. The wavelength is longer. That's it. The conversation will be over right there. The issue with your diagram is that you don't show that the atom is slower than the bits. Can't matter how fast I make it. Obviously, the faster I make it, the more of an effect it's going to have because the trap is moving more distance. But it can't matter to the theory. We're arguing the theory. You're saying it doesn't matter that it's moving. Okay? You're not saying, well, it has to be moving a certain speed for it to matter. No, you're not making that argument. So let's not play a game like it matters what speed it's going. The critical problem at 11:09, fuck you, you depict both arrows as of equal length. They are of equal length in the sense they all have the same wavelength going in. So, yes, they're all equal length. And then when I did the reverse thing, okay, I didn't make them as long going this way just because obviously the B element will hit before it gets all the way to B. B's not stopped, it's still moving, so it's going to hit it sooner. But the point is for the sake of the argument, we were just going to say, let's just show it as it would be. So clearly all you can argue is that it wouldn't double. It would something less than double. But it'd still be more than one. So again, you're not arguing the theory. You're arguing minutiae that can't matter. The proportions isn't making the lines longer. Okay, the fact that I doubled them rather than 1.438, because I didn't do that, doesn't change the fact that it's more than one. All right. Moreover, it will release the bit when it meets the third bit. So again, when it meets doesn't really matter. I just did for the sake of the argument, just said only one at a time, and let's just make it when one leaves, the other one goes in at exactly the same moment, just to eliminate the extra remainders, just to make the mathematics simpler. But no, don't do that. Keep the bullshit in there so you can hang it on nonsense that doesn't matter. Alright, anyway. Alright, moreover, it will release the bit when it meets the third bit, but that's going to happen midway. Yes, I concede that. And that's the way I drew it. If you look at the way I drew it, if you actually look, you'll see I didn't draw the arrow going all the way to B. I drew it a little halfway-ish. So I did do that, asshole. The red and black arrows have to be halved because, so again, you're just arguing because, for the sake of argument, I was just saying let's just pretend it's a full length of the wavelength, just to get rid of remainders. So again, you're just arguing, oh, my lines shouldn't be 2 lengths, they should be 1.5. We still know that 1.5 is more than 1. So we still know I'm right and you're wrong. Alright, we'll meet another new bit midway through the wavelength, assuming it goes close to the speed of light. So again, it's totally irrelevant when it meets. Again, I could argue the same case, the exact same thing would happen if I, by some magical way, put the 4th bit in the trap first, and then put the 3rd bit in second, and then put the 1st bit in third, and then put the 2nd bit in last. Exactly the same consequence, because they're individual events. Alright. Assuming it goes to the speed of light. Okay. Like I said, that bullshit. So you just made a bullshit argument from irrelevant technicality. Okay, the argument from irrelevant technicality, because all you can argue is my line was a little longer than it should have been. But it wasn't wrong. It should be longer than 1 unit, because it's more than 1 unit, is the fact. The wavelength has increased. Alright, like I said, let's put down some specific numbers. Now, fuck you. Why don't I tell you to put down a specific drawing? I've done this myself, which took some effort. Oh, you put down numbers. Well, fuck you. I want a drawing. It's on one plane, okay? It's not 3-dimensional. It's not that complicated to draw. Draw it. Draw how it doesn't change anything. Going backwards doesn't change how long it takes you to get somewhere. You can walk to the store. It's 21 steps to the store. I can stop you, force you to go backwards 2 steps, and you're going to get to the store at the same time. Fuck, you're not. So this is going to illustrate something. I don't think so. So each unit goes through the same thing. So the only thing good about this is every single unit goes through the same process. It enters, and then it goes backwards, and then it leaves. And that's all that's just happening here. So all you have to do is draw the line. Here's the atom. The thing enters. Once it enters, it goes backward, and then it leaves. So all it's doing is having to redo these steps. And having to redo these steps means it's going to take just as much time as it took the first time to do those steps. Those 4 steps took a certain amount of time. Those 4 steps on a staircase, let's say, will have to be re-stepped. It'll take a certain amount of time to do that, ergo longer wavelength. So your drawing just illustrates my point. As far as I'm concerned, besides the fact you have the things moving the wrong directions. Photon going this way. Okay? Photon going this way. I don't know. They're not even labeled. So this took a long time. I mean, it would take me a long time just to make the ruler, so I'll give you credit for that. But this doesn't illustrate anything for my mind. You need to make a series of steps. Here's what happens in step 1. Here's what happens in step 2. Here's what happens in step 3. And here's what happens in step 4. That would be helpful to me. I'll try to draw it again, but I'm just saying there's nothing to draw. If we agree they're isolated events, that one event doesn't affect the other events at all. So when one goes in, something happens to one, and it only happens to one. So like I said, on the horse race example, I'm going to do something to the fucking horse. Just the one horse at a time. It doesn't matter where the other horses are doing, where they're going, what they're doing. It doesn't matter. I'm going to work on one horse at a time, and the event isn't going to throw something at the other horses. It's not going to trip them. It's not going to throw mud in their eyes. It's not going to affect them at all. It's just going to affect the horse that's being affected. The horse that's in the atom is only the horse in the atom. The photon. Okay. In this illustration, the bits are initially 8 units apart. Okay. Between each picture. There's pictures. I didn't see more than one picture. What happened to the image? I closed it? Strange. Puro video. Yeah, hard to watch. Actually haven't. Yeah. I can't believe I closed it already. I guess I was that uninterested, huh? Alright, try again. Alright. So I only see one image here. Oh, okay. It has a series of them going down. Okay. Alright, so now this was a lot of work. Alright. So he has the photons going this way and the atom going that way, which just, fuck. What? I don't know. I don't know if I can make any sense out of this or not. Don't know. I mean, obviously it would help to have it all on one page, but, it just doesn't. So, look, to make it simple, don't bother showing all the photons. Just do one at a time. Just do one photon, and you'll see it automatically gets a lengthened wavelength, the one photon, in the sense that it will arrive at the destination a little bit later because it's longer than it was before. Period. That's all. We're done. Obviously, I have to go through all those images and try to figure out what he's done here. Okay, the bits are 6 units a second to the left. The atom moves 2 units a second. See, this really doesn't matter. Just say 5 miles an hour, 10 miles an hour. This doesn't matter. It doesn't even matter this mile to mile. All we're talking about is distance. Just do the distance as time, a unit of time. And it moves a certain amount of distance. I just can't see how it matters what units I give it. It's going this way. I stop it from going this way. The clock is still moving. I stop it. Clock is still moving. And I put it backwards from where it was. Clock is still moving. Now I let it go. Clock is still moving. And it has to undo the distance I put it backwards. What are you missing? How can you miss that? Alright. When the atom absorbs the bits, it holds it for 1 second only. Take multiple tabs to open these 4 and compare them tab to tab. No. Said, isn't it the same image already opened? Yeah. Why would I put them in tabs? How would that help? Yeah, I don't think I'll do that. But thank you, but no, I don't think I'll do it that way. I don't like that these appears that you have the photons moving the wrong direction, which confuses the hell out of this. I mean, I started it. The directions, you should have stayed with the same directions I was using. Alright, so anyway, see what Michael has to say. Hi Gary, hope you ate doing well. Ate, well, yeah. Ate ain't a word. Anyway, this topic has certainly raised a bit of interest. So the argument is simply that if a matter bit and a force bit are moving towards each other, would it affect the frequency? Yes, of the group. 1. Imagine a train on the length of track 60 miles long. And the train traverses a distance of 60 miles an hour, yes. And at each mile point there is a ball hanging, and the driver holds it for say 1 minute and then drops it from the train. So if at the start of the journey the first ball is collected at 0 mile point, then the first ball will be dropped at the 1 mile point, and the second ball will be collected at the 1 mile point. So he's grabbing the ball, the train travels, and then he drops it. Got it. And then the second ball, and so on. The frequency has remained the same. Let's see what it says here. Then the second ball will be dropped at the 2 mile point, and the third ball collected, and so on. And all the balls will still be 1 mile apart at the end of the exercise. So we can say that the frequency has remained the same. Yeah, well, frankly, it doesn't have any place that you take the ball and move it backwards, but okay. Now, same rules. Ball is held 1 minute by the driver, then dropped. Train is traveling 60 miles an hour over distance. Now, the hanging balls are on a conveyor, still spaced at 1 mile apart, but traveling towards the train at 60 miles an hour. Yes. But you're still going to have the problem of the conveyor. Once they're off the conveyor belt, they're not moving. So yes, you're picking them up off a conveyor belt, and now you're creating more distance. Okay, so again, the first ball is collected at 0 mile point. So I don't know if this analogy helps, just because you have to. Now you have the train moving this way. You have the conductor picking things off the conveyor belt moving this way. Yeah, the problem with that analogy is the conveyor belt will be doing the moving and not the train. The train takes it backwards at the train speed, not the conveyor belt speed. But if you make the two conveyor, if you give them the same speed, then I guess it doesn't matter. They'll be collected and so on. So at the end of the exercise, the balls would be 0.5 miles apart from each other. So I would simply argue that increased frequency in results in increased frequency out. I don't think that makes any sense, but the point is, as far as I'm concerned, the only point is while something is part of something else, it's part of it. If the trap is the trap, I mean, it's like me stepping on a train. If I step on a train going the opposite direction, and I step off the train, I'm going to be further back. There's just no way of getting around it. Alright. So we'll try one more person and give it a shot. I picture a cannon mounted on a railroad trolley. The trolley is traveling at the speed of the photon. Then the cannon fires a photon. A photon can't fire a photon. The photon won't go anywhere if it shoots it forward. And if it shoots it backward, well, then we have another conversation. Then it fires a photon. Then it fires the photon. It pushes the cannon backward on the same track in a matter of recoil. Now, this has nothing to do with recoils and all that crap. That will just make a mess of things. It falls into the trap. There's no recoil. It falls into a trap, and then it falls out of the trap. So it's like a staircase. It's the roof has a hole in it. It flies in the hole in the roof. Okay, it wastes some time going down, and while it's going down, the house moves backwards, and then it starts to fly again here, coming out the window on the first floor, and it's now got a fly distance it already flew. Following the delay, the trap, the trolley, and the cannon resume its trajectory and velocity on the track. Well, okay, that's not going to help. I made a video response where I came to the same conclusion that the wavelength doesn't stretch. I'm just saying anybody should know that the wavelengths don't stretch. I mean, they're produced. I mean, do people really think that the sound coming off the back of a train is being stretched? You know, while it's moving through space, like somehow the extra space is stretching the wavelength? Or do they understand that no, the train's moving a further distance away, so the wavelengths are automatically longer because there's more distance between you and the train? I mean, God, this isn't a conclusion that I should have to even argue that wavelength isn't a I mean, the redshift and blueshift isn't a consequence of stretching space. It's a consequence of pushing, letting things go while you're moving closer or while you're moving away, while you're creating less distance or while you're creating more distance. Shit. All right, we'll see what the video response is like. This is so frustrating. Oh, 42 seconds. I don't think so. Each picture will be shown for 5 seconds, so press the pause button on each time. I don't really want to do that. So keep in mind that each photon is trapped inside the hydrogen atom for 1 second. Okay. So it's the same kind of drawing. Plus numbers, minus numbers. Which I don't think is very helpful, but fine. Alright. So there's the photon moving at the right. So it's moving right. Doesn't matter what speed. The hydrogen atom's moving left. Doesn't matter what speed. Oh dear. So we got back to the 2's again, which we don't need. We really should all be able to agree that what happens to each individual photon, and while it's happening to this one, it doesn't make a damn bit of difference to anything else in the universe. It's not affecting anything else in the universe, it's just affecting the photon that's in the trap moving backwards. Okay, move to here. Photon moving to the right. This, I can't make any sense. Hydrogen moving to the left. Nope, can't make much out of that. Alright, photon 2, photon 1, photon trapped for 1D. Photon 1 is trapped. No, you got two people in the trap at the same time. Just no point. All right, so this doesn't really work for me. Sorry. I appreciate that people are going to this effort. So yeah, so I'll engage in the conversation as best I can. I mean, I think I've made the arguments over and over and over, and I just don't see why I have to keep making them, but I'll try to draw it one more time. I'll try. I'll just keep emphasizing how maybe I can show you that they're individual events. You don't need to worry about it's moving towards number 2 and it's moving away from number 3. You don't have to worry about any of that. The extra... I'll draw it. And then the happy squirrel said to the happy chipmunk... Could do a little painting. Anyway. Simple principle. Okay, so these individual events will happen. So I'm just saying, okay, we know that this has a wavelength, a distance. And the thing it's going to hit is moving that way. Right? I mean, that shows up the right way, right? Yeah. I don't know why people are drawing it opposite. I just don't know. So this is the hydrogen atom. All right. Now what's going to happen is just imagine these things don't exist because it just doesn't matter. It doesn't matter that these are here or not here because it can happen to one single bit. And so just understand that what's going to happen is the hydrogen atom is going to stop the forward motion, so it's going to stop moving forward. So that's essentially, you could just say it's moving down now. Same difference. And the hydrogen atom is now going to carry it this way. Right, so it went this way, heading for a target. And now it went down, and then went over. Now if it hits just an atom that's not moving, maybe we could all agree, okay, that the only thing it's going to do is go down. It'll never go backward. And so it'll just go down, creating a delay in time. And so let's say it takes 3 seconds when you hit a hydrogen atom that's not moving. So when you hit a hydrogen atom that's not moving, it takes 3 seconds to get from this point to the target. 3 seconds. Alright, so you're going to do exactly the same thing. You're going to take 3 seconds going down. So this is 3 seconds worth of time. Okay, and just ignore this part. I mean, you could just draw it this way and say that takes 3 seconds. But I'm just saying, while it's doing this, it's doing this. It's moving backward. Alright, so now it's here. Alright, okay, after the 3 second delay. So after the 3 second delay happened, in the two scenarios, in one scenario where the hydrogen atom isn't moving, it would be here. And then it would take 3 seconds to get to the target. This one is obviously going to take more than 3 seconds because it's moved backward. And now it has to redo this distance a second time. Sorry about the glare. It has to redo this distance. And so that's the increase in the wavelength right there, that extra distance. And we know that this will arrive at the destination 3+ seconds plus this extra. And each single event that happens, each time this, if it happens every 10 minutes, the photons had a wavelength of 10 minutes, right? It doesn't matter how far apart I make them, doesn't matter. Each time it happens, this will happen. This extra distance will have to be traveled. That'll take extra time. Extra distance, extra time. So it shows up later than it should. And it shows up later than it should because it traveled extra distance, which is the extra wavelength. That's the extra bit on the wavelength is exactly this. The amount of distance you went backwards is the extra distance you have to travel to finally get to the target. There's no way to undo that. So it happens to each one. A gets lengthened B gets lengthened, C gets lengthened. The increase is put into each one. And the proof is, okay, that you can understand the proof, is that clearly if the hydrogen atom isn't moving, there's not going to be any more delay than the time this takes. And if it is moving, there's going to be this extra distance and extra time that it's going to take to get to the target. Just a fact. It's just a fact. You can't undo it. So you don't have to worry about the two speeds, because all of this will happen at the same speed. Redoing this distance, making up the distance you lost, it's going to be doing that at the same speed it was doing this. Oh, damn it. The same speed. So there's no difference. The speed is irrelevant. And this is all that happens. There's no other events that happen to each photon is just one event. There's no, this doesn't spill into the other photon somehow. This is happening to the one, each individual horse is having this little bit of extra distance. It's being obligated to run. This bit, it already ran once, and now it's got to run it again. Yeah, that really should be enough. I mean, it's so simple. You know, I'm sorry. You people are just being belligerent. You know, denialists. Clearly, there's more. Just concede the point. If I just had one little ball, one marble hits the other marble by the rules I've said, where the marble sticks to it and it ends up going backwards, you can understand it'll take longer for the marble to get to the target, because it has to travel this distance twice. You got to get that. And so it's happening to each photon. It's having its wavelength increased, which is increasing the, obviously, the total distance. Each increase increases the total distance. The total distance is being increased because the hydrogen atom's moving this way, and it keeps doing, I'll force this one to run twice, and I'll force the next one to run twice, and I'll run this one twice. All those count, just as they count right here. Just as you can see it visually, there it is. That's the extra wavelength. Right there. Right there. The amount you go backwards is the amount you add to the wavelength. I didn't know. You want me to say it? Shouldn't have taken 7 videos. Shouldn't. So, do you concede they're individual events that have no consequence on the other photons, especially if I make them far enough apart? There's no way what happens to the first one while it's in the trap has anything to do with anybody else. A, B, C, D order, none of that could matter because it can't leak onto any of those events. So, they're individual events, and the individual event undeniably just has extra distance in it. Okay, yes, no, I can't do it. I can't make it any plainer. I really think this is the last one. I mean, it's right there. Where have I made a mistake? Where has this a fake amount of distance? It's not a fake amount of distance, and it's all at the same speed, the speed of light. There's no way you can miss it. I go up 4 stairs, I go back 1 stair, then I go back up the stair. I have to re-step on the stair I already stepped on. It's got to take me longer. Fuck. Alright, yeah, it's enough. It's enough. Okay, so till the next time, when we should be on a new subject. It really should be. It really should be. Alright, anyway, till next time.